Ms. Humbert here, and today we're going to be doing Unit 8, Notes 7. So we're going to be talking about the distance formula. I just sounded Canadian there. About the distance formula. Super cool. All right, so let's take a look at this one. A certain helicopter can fly 450 miles before it needs to refuel. Suppose a person needs to be flown from a hospital in Minneapolis to one in Chicago. Chicago is 225 miles east and 170 miles south. Can the helicopter make the trip one way without refueling? Well, let's think about this logically, right? It wouldn't really make sense for us to go all the way down this way and then all the way over this way, right? We would cut across this way. So we need to figure out what that length is. And we can do that using the Pythagorean theorem because a compass forms a right angle. So we're going to have 175 miles squared plus 225 miles squared. That's going to be equal to our distance squared. So 175 squared is 50,625. 225 squared is 15,625. And that's going to be equal to x squared. So when you add those together, you end up getting x squared is equal to 66,250. So we want to figure out if the square root of this is less than 450. So when you take the square root, you end up getting 257.39. miles. Is that less than 450? Yeah, it is. So yes, the helicopter can make it all the way to Chicago. All right, let's take a look at the distance formula. So the distance formula is used to calculate out the distance between 2 points. Okay, so x1, y1, and x2, y2. So notice that x1 and y1 are in the same parenthesis, and x2 and y2 are in the same parenthesis. So that's the distance formula. You really want to make sure you get it down. So you subtract your two x exponents and square it, and you subtract your two y exponents and square it. Or coordinates, sorry, not exponents, where I'm getting that word from. All right, so let's go ahead and let's calculate out the distance between these 2 points. So sometimes it helps me to label the points out. So I have x1, y1, x2, y2. So what I have is I have y2 minus y1. Oops, sorry, it's x2. Not that it actually really matters, but let's just keep it the same. So we have x2 minus x1 plus y2 minus y1. Now remember that when you subtract a negative, it becomes plus a positive. So 11 minus 5 is 6. So I have 6 squared plus 7 plus 1 is 8 squared. So I have the square root of 6 squared plus 8 squared, which ends up being the square root of 36 plus 64, which is the square root of 100. And I know that the square root of 100 is a whole number, and that is 10. So the distance between those 2 points is 10 units. Let's take a look at number 2. So for number 2, we're going to do x2 minus x1 squared plus y2 minus y1 squared. Add those up. So 17 minus 2 is 15 squared plus 4 plus 4. Remember, when you subtract a negative, it becomes a positive, and you get 8 squared. So then you end up getting the square root of 225 plus 64. The square root of 225 plus 64 is going to be the square root of 289, which again is a perfect square. So you get 2 square root of 13 for your final answer for number 2. Let's take a look at number 3, calculating out the distance between those 2 points. So I'm going to do x2 minus x1 and square it, and then y2 minus y1 and square it. So then I end up getting negative 6 squared plus 3 squared. Well, be a smart calculator user here. You guys know that when you square negative 6, it's going to be a positive number. You're going to get a positive 36. The only mistake students make on this is telling me that a negative number squared is negative. And then 3 squared is 9. So then you end up getting the square root of 45. So when you break down 45, we're going to break that into a simplified radical. 9 I can break down to 3 and 3. So there's a pair of 3's I can take out. So I'm going to take out those pair of 3's, and left underneath the radical is 5. So I have 3 square root of 5 for number 3. Next, let's take a look at number 4. So for number 4, we're going to calculate out the distance. We're going to do x2 minus x1 plus y2 minus, that's going to become plus a positive, y1. Whenever you subtract a negative, it's going to become plus a positive. So you're going to get negative 6 squared plus negative 4 squared. You're going to take the square root. So that's going to be the square root of 36 plus 16. So you get the square root of 52. And we can simplify the square root of 52 out. So 52 we can divide into 4 and 13. 4 we can split down to 2 and 2, so we can take out a pair of 2's. So it's going to be equal to 2 times the square root of 13 for your final answer. Now let's take a look at this golfing problem. So Tracy's golf ball is 20 feet short and 8 feet to the right of the cup. So let's put the cup. We'll put the cup at the point 0, 0. So the cup's going to kind of be at our origin. So she is 20 feet short, and 8 feet to the right. So since I'm short, I'm going to go down. Oops, I want to go how many I went right over. So 8 and negative 20. Now when you're setting up a coordinate point, first you write how many you go over for the x, and then how many went down. So this is where she's starting right here. Then she shoots it, and it lands 2 feet to the left and 3 feet beyond. So then this is going to be the point, negative 2. Whenever you go left, it's going to be negative, and then it's going to be up 3. So we want to calculate out the distance between those 2 points. So it doesn't matter which one you choose for x1, y1. Let's have this be x1, y1, x2, y2. So you're going to do the square root of y2, or x2. Why do I keep doing that? Golly gee willikers. So I have x2 minus x1, that's going to become plus a positive, plus y2 minus y1. So then you end up getting the square root of 10 squared plus a negative 23 squared. Now remember, whenever you square a negative number, it should become positive. So I get the square root of 100 plus 529, which is equal to the square root of 629. Now let's see if we can simplify that number out. So I just started dividing it by random numbers. So 629 divided by 3. Well, that's not a whole number. And I kept dividing, and I kept dividing, and I kept dividing, and I actually couldn't find any pairs. So believe it or not, 629 is completely simplified. So now I just need to label it feet. So that's the distance that her ball went when she hit it. Let's take a look at number 6. So it says on her college campus, Kelly has her first class in Rhodes Hall, her second class in Fulton Lab. How far does she have to walk between her classes? Okay, so what I'm going to do is I'm going to call Rhodes Hall 0, 0. That's going to be the origin. That's going to be our point. Then you'll notice we're going over 1/4 and then over 1/8. Here's a hint for you. 1/8, or not 1/8, 1/4 is the same as 2/8. Okay, so 2/8 plus 1/8 is 3/8. So we're going over 2/8 plus 1/8. So we end up going over a total of 3/8. Remember, how many you goes over, that's what goes in the x-coordinate. And then, how many are we going down? We're going a negative 3/8 mile. So now we need to calculate the distance between those 2 points. So let's go ahead and let's do that. So we're going to have square root of x2 minus x1 squared plus y2 minus, y1 squared. Oops, I flipped those around. y2 minus y1 squared. So then what we end up getting is 3/8 squared plus a negative 3/8 squared. So when you square those, you can actually just distribute the square into the fraction. So 3 squared is 9, 8 squared is 64, negative 3 squared is 9, 8 squared is 64. So when you add those two fractions together, you end up getting the square root of 18, way to go, Miss Humbert, over 64. You can add those two fractions together because they have the same denominator. So now I'm going to split up those two radicals. I'm going to have the square root of 18 on top and the square root of 64 on the bottom. Well, the square root of 64 is just 8, and then I have the square root of 18 on top. So I need to break down the square root of 18. So the square root of 18 I can break down to 9 and 2, and then 9 I can break down to 3 and 3. So then I'm going to take out a pair of 3's, and left underneath the radical is 2, and that's going to be divided by 8. Well, I can't simplify down the fraction 3/8, so that's going to stay as is. So then our final answer is going to be 3 square root of 2 divided by 8 miles for our final answer for number 6. Now let's take a look at how the distance formula works. How did we get it? And it actually kind of comes from the Pythagorean theorem. So let's say we're doing this, and we're going to call this point 6, 0. And then we're going to go up 4 here, and we're going to call this point 0, 4. Okay, so there's a couple ways we can do this. I know that this distance is 6 and that this distance is 4. So what I'm going to do first is I'm going to calculate this using the distance formula. Maybe. So I'm going to do the square root of x2 minus x1 plus y2 minus y1. And then I end up getting the square root of 6 squared plus a negative 4 squared. And then I get the square root of 36 plus 16, which is the square root of 52. Now I'm going to be a bad teacher and leave that radical unsimplified because I really want to see the comparison. Now I'm going to do this as a Pythagorean theorem using the length of 6 and 4 for the legs. So 6 squared plus 4 squared is equal to x squared. 36 plus 16 is equal to x squared. X squared is equal to 52. Take the square root of both sides, and you get that x is equal to the square root of 52. So the distance formula actually comes from the Pythagorean theorem. We just use the distance formula when we're given coordinates. It makes it easier when we're given coordinates. So let's take a look at some of these problems here. So find the possible values of a if the distance is 10 units. So I'm just going to set up my distance formula. So I'm going to have x2 minus x1 plus y2 minus y1 is equal to the distance of 10. First, let me simplify underneath the radical. So I have a minus 7 squared plus a negative 8 squared is equal to 10. The square root of a minus 7 squared, I'm just leaving that as is, plus 64 is equal to 10. So what I'm going to do is I want to get rid of that square root because the square root's isolated, right? That's what we talked about when we talked about solving radical expressions. So I have a minus 7 quantity squared plus 64 is equal to 100. So now I'm going to subtract that 64 over to the other side. So I get a minus 7 quantity squared is equal to 36. So now I want to get rid of that squared that's there. So I'm going to go ahead and I'm going to take the square root of both sides. So I get a minus 7 left over here is equal to 6. So now all I have to do is a simple solving radical expressions. So I'm going to add 7 to both sides, and I'm going to get 6 plus 7 is 13. And that's your final answer for number 7. Let's take a look at number 8. So for number 8, again, we want to solve this out. So we're going to have the square root of y2 minus y1, quantity squared, plus x2 minus x1, quantity squared, and that's equal to the square root of 58. So I end up here getting the square root of negative 7 squared plus 5 minus a squared is equal to the square root of 58. So then I get the square root of 49 plus 5 minus a quantity squared is equal to the square root of 58. So now I'm going to go ahead and I am going to square both sides to undo that square root. So left over here I have 49 plus 5 minus a quantity squared. And when you take the square of a square root, you're just left with the number that's there. So now what I'm going to do is I'm going to subtract that 49 over to the other side so I can isolate my squared term. So I have 5 minus a squared is equal to 9. So now I want to undo that squared, and I'm going to undo it by taking the square root. So over here I'm left with 5 minus a is equal to 3 once you take the square root. So I'm going to subtract 5 from both sides, and I get negative a is equal to negative 2. Then I'm going to divide both sides by a negative 1 because I don't want to know what negative a is. So I get that a is equal to 2. So that's your final answer for number 8. So that concludes your note video for today. Please make sure you get that Schoology quiz taken.